All right, today we're driving into an absolutely incredible project from Mountains of the Moon University in Uganda. And it tackles a problem that every single one of us deals with every single day: trash. But this isn't just about taking out the garbage. This is about making the garbage can smart.
I mean, it sounds like a simple question, doesn't it? Could a trash can actually be smart? But the answer? Well, it's surprisingly cool, and it could be a massive game changer for sustainability. So let's get into it and see how one student project is turning this very question into a reality.
Okay, first things first. Let's just set the stage. Waste is a huge and growing problem. And we're not just talking on a global scale. It's an issue that comes right down to a single university campus. It's a challenge that is crying out for some new ideas.
So just how big of a problem are we talking about? Well, check this out. The World Bank projects that by the year 2050, the world is going to be generating 3.4 times billion tons of solid waste every single year. That number is it's hard to even wrap your head around it.
And if we zoom in on Uganda, which is where our story is centered, it gets even more specific. The National Environment Management Authority there reports that an estimated 60% of all solid waste is disposed of improperly. And that, of course, leads to some really serious damage to the environment and creates major health risks for people.
And this is what that global issue looks like on the ground. This quote is pulled right from the project report, and it paints a pretty clear picture of the situation at Mountains of the Moon University. You can call it MMU. Before this project got started, this was their reality. It was a daily struggle.
The report really breaks down just how messy the old system was. You had cleaners sorting all the trash by hand, which is super slow and, mistakes are going to happen. Wet food scraps would get mixed in with dry paper, contaminating the recyclables and making them useless. Good compostable stuff was just getting thrown out, and the staff were wasting so much time and energy running around checking bins that were only half full. The system was just broke.
But right in the middle of this challenge, a really brilliant and practical solution started to take shape. And this is where things get really interesting. This is where technology goes head-to-head with trash.
And here it is, the project at the very heart of this story. It was created by a computer science student named Bright Emanuel, and it's just the perfect example of someone taking what they learned in the classroom and applying it to solve a very real, tangible problem they saw every single day on their own campus.
So what do we actually mean when we say smart waste management? Well, basically it's all about using modern digital tech, things like the Internet of Things, or IoT, to completely automate and streamline the entire process of handling trash. We're talking everything from sorting it the moment you throw it away to monitoring exactly when the bins need to be emptied.
The project's goals were crystal clear. First, automate the sorting process to take human error out of the equation. Second, use sensors to know exactly how full every bin is in real time. The result of all that? A cleaner, much more efficient, and a way more sustainable campus.
Okay, so this is the fun part. How does a smart bin actually work? Let's pop the hood and take a look at the technology that makes it all happen. At the very core of this whole system is this tiny but really powerful ESP32 microcontroller. The best way to think about it is as the bin's brain. It takes in all the information coming from the sensors and, in a split second, decides what to do with whatever piece of trash was just thrown inside. Now, for the brain to work, it needs senses. So the system has a nose, and that's the moisture sensor. Its job is to figure out the difference between types of trash. It can instantly tell if something is wet, like food scraps that can be composted, or if it's dry, like paper or plastic that can be recycled. And to solve that annoying problem of overflowing bins, the system also has eyes. These are ultrasonic sensors, and their job is to constantly measure how full each compartment, the wet and the dry, is. The second a compartment starts getting full, the brain knows about it.
So, we have a brain, a nose, and eyes. The last piece of the puzzle is the hands. That's the servo motor. As soon as the brain makes its decision, the servo motor jumps into action. It physically rotates a little flap inside the bin to guide the trash into the correct compartment. It's that simple.
So let's just put that all together. Somebody throws something in the bin. The system detects it, the nose analyzes if it's wet or dry, the hands flip it into the right compartment. All the while, the eyes are checking the fill level, and if it gets full, boom, an alert is automatically sent to the cleaning staff's app. The whole thing is just a seamless, automated process. Of course, building a prototype in a lab is one thing. Making it actually work in the chaos of the real world, that's a whole other challenge. So let's take a look at how the system actually performed when it was put to the test.
You know, one thing I really appreciate here is how open they were about the problems. The report doesn't just talk about the wins, it details the challenges. The servo motor was inconsistent, the power supply was a bit unstable, but for every single problem, they came up with a clever engineering solution. This is what real innovation looks like. It's about solving the problems you didn't see coming. When you put the old way next to the new way, the difference is just night and day. You go from a manual system that was slow, full of errors, and really inefficient, to a smart system that's automated, accurate, and totally optimized because it has real-time data.
And the results really do speak for themselves. Sorting accuracy went way up. Overflowing bins, they became a thing of the past. Collection schedules were optimized, which saved a ton of time and money. It was even safer and healthier for the staff. And the best part? All this data was available in real time on a simple app.
So this project has already proven it works and has incredible value. But the report didn't stop there. It also looked ahead to the future, asking the question, how can we push this technology even further?
And the recommendations for what's next are genuinely exciting. Imagine adding machine vision so the bin can literally see and identify what you're throwing away. Or using machine learning so the system actually gets smarter and more accurate over time. But the biggest opportunity and the biggest challenge is scalability. How do you take this from a campus project to a solution for an entire city?
And ultimately, this is why this whole thing matters so much. This project is way more than just a clever gadget. It's a model. It's proof that a local, student-led, tech-driven solution can make a real, measurable dent in a massive global problem like waste management. And that really just leaves us with one final thought. This project took one of the most mundane, everyday objects imaginable, a simple trash can, and completely reinvented it. It really makes you wonder, doesn't it? What other everyday objects are all around us, just waiting for a smart, sustainable reinvention?